Okay, laws of friction. So what are the laws of friction that we will discuss? Means how much force of friction will be acting on an object. Those things we are going to discuss. So we will see different things on which friction depends. So the first point is the friction force between body and the surface is independent of area of contact. So what does it mean? Means if you have larger surface area or a smaller surface area, the friction force does not depend on that. Okay, so that actually that in day-to-day life, if we try to compare this example with day-to-day life experience, it seems that how it is possible actually. It means generally we think that larger the surface area, more the friction will be, but that is not the case. So I am giving you an example here. Suppose I have a surface and I have a brick. A brick is placed like this, and the same brick, if I place it like this, okay, so in this two orientation, if I put the brick like this, so in the first case you can see the surface area in contact with the table is small. In second case it is large. So if you try to push this whole object, both the objects, the friction developed in these two cases are not going to be different. They are going to be same. So the area of contact is not the deciding factor here. So that is the thing which is said in the first statement. The area of the force is independent of area of contact. So in whatever orientation you keep, that is not an important thing. Second point is frictional force is always directly proportional to normal reaction. So what is this? So the more force you apply, the more normal force you apply, the more friction you will have. So how it is how can we justify it? How can we give some example? So if you have some object, okay, and if you are trying to pull it, so if you apply some force and you can pull it, okay, so some normal force is there between this surface, some normal is acting, and you are trying to pull it, so you will be pulling this object by applying some force. Now if another person, some person is sitting on this, if a person sits on this box, suppose a person is sitting on this box, then what will happen? Because of his weight on the box, the normal force will increase. As the normal increases, the friction will increase and it will become difficult to move this object. Okay, so that is the thing which is said in the second statement. The friction force is directly proportional to normal. So if normal here is increased, the friction has to increase. Okay, and it is not gravity. Okay, it is not gravity. The normal force is coming from gravity. That is different thing. But the gravity is not directly responsible for friction. That is the normal force is responsible for friction. I am giving you another example where gravity is not playing role. Suppose you have a soap, the wet soap is there. You want to hold it in your wet hand. Okay, so normally if you hold the soap, a wet soap, if you hold a wet soap from your wet hand, if you hold it lightly, the soap may fall from your palm because of the less friction provided by your palm to the soap. But if you hold it very tightly, then you can it may not slip. So why is that happening? Because when you hold it tightly, you are pressing the soap with larger force and you are applying the more normal force from your fingers on the soap. In that case, the friction force also increases. So what does it mean? It means that if you apply large normal force on any surface, the friction force will also increase proportionately. And in this case, you can see in the case of soap, there is no gravity actually. You are applying the force by your fingers. Okay, so the normal force which you are applying at the contact surface, that is the main responsible thing. Okay, next is both these laws are applicable to static as well as kinetic. So these two laws which we discussed above are applicable for kinetic as well as static friction. Okay, if N is the normal force, then the frictional force is given by F proportional to N. The friction force is proportional to normal. And if you write the proportionality constant, F equal to mu N. And what is this mu? The mu is called coefficient of friction. Okay, so if you apply some normal force on a particular surface, and if you apply the same normal force on some other surface, the friction force may be different. Why? Because the surface may be of different type. A surface made up of ice will have much less friction. So mu will be very small. The mu or coefficient of friction will be very small for a smooth surface, and mu is large for a rough surface. Okay. So coefficient of friction is what? It is defined as the ratio of frictional force and normal force. And it depends on surface. It is property of surface. This is property of surface. Property of, actually it is property of surfaces in contact, both the surfaces in contact. Okay. It has no unit and dimension. It can be determined experimentally. It depends upon molecular nature of the surface in contact. Okay. So if two surfaces are in contact, if whatever is their internal structure, bond, how is their bond there present in the objects, and how is what is the molecular nature, all these things decide how the friction force will be there, how the coefficient of friction will be there. Okay, so those things are decided by the surface. Dust and impurities on the surface drastically affect the value of friction force. So if you have some dust and impurities on the surface, obviously the friction is going to change. Friction coefficient will change. So now we will see law of static friction. So static friction is also having the similar laws which we discussed. That was the common, and that we are discussing for static friction. So limiting friction is independent of area of, limiting means what? Maximum value of static friction. Okay, is independent of area of contact as long as the normal reaction same. Limiting friction depends on the materials of the surface in contact and their state of polish. State of polish means how the surface is, means whether it is smooth or rough. Then limiting friction is directly proportional to magnitude of normal reaction between the two surfaces. So this law we can write whatever we wrote earlier. So that was common for static and kinetic. So the same thing we are writing separately. Okay. So this is the limiting frictional force, the maximum value. This is actually maximum value of static force. Okay. So friction is static, if you write, it is less than this much. The static friction is less than this value. Okay, so we should write this equation. And this is the limiting value, the maximum value. The static friction force Fs is less than normal when the bodies do not slide over each other. Okay, now you have different values. You can see that for ice and ice surface, if you have two ice in contact, the friction is very, very small. You can see only 0.1. If you have wood and wood, a wood surface sliding over a wood surface, the friction is roughly 0.35. Obviously, it will depend on the type of surface also, how smooth and how rough it is, but it is an approximate value. Wood and metal, 0.4. Rubber tire on wet concrete road. So on a wet concrete road, means during monsoon season, that is 0.7. And glass on glass, that is 1. So glass, it is very difficult to slide glass on glass. The friction coefficient is having large values. Okay. So these are just for idea how these different object surfaces behave in contact with friction. Okay, law of kinetic friction and rolling friction. So for kinetic friction, the kinetic friction force is directly proportional to normal reaction, same as static friction. And you can write Fk equal to mu k into n. It is independent of area of contact. It is proportional to magnitude of normal force at surface. Here mu k is called coefficient of kinetic friction. Kinetic friction is also independent of velocity. Means, since kinetic friction is not, one object is moving with respect to other. Okay, so that is independent of velocity. Kinetic friction is independent of velocity. That is also there. Rolling friction. So what is rolling friction? The rolling friction is directly proportional to normal reaction, and it depends on area of contact. Okay, so whatever is the area of contact for a rolling object, that is also deciding the rolling friction. If the area of contact is less, the rolling friction is less. If area of contact is large, the rolling friction will be large. So how do you decide area of contact? If you see small sphere, the area of contact will be very small. If you consider large sphere, the area of contact will be large. So on larger sphere, the friction will be larger. If the radius of a rolling body is more, then it possesses less rolling friction. Okay. If radius of rolling body is more, it possesses less rolling friction. Okay. Yes, it is less rolling friction. Okay. So what I was saying was, so if the area of contact is not in that constant, area of contact in actually for a rolling object, the area of contact is only a point. For a rolling object, if you say the area of contact is what? For a rolling object, area of contact is just a point. Okay, so if we say that area of contact is small, means it should be just 1 point, or if we have 2 points, suppose like this, if we have something like this kind of surface, so in that case we have the more area in contact. So in that case the friction will be more. Okay, the coefficient of friction of rolling is the ratio of rolling friction force to the normal reaction. Okay, so this thing we can write, coefficient of friction is ratio of rolling friction force to the normal reaction. So again we can write this expression. For similar surfaces, the coefficient of rolling friction is smaller than the coefficient of kinetic friction. For similar surfaces, the coefficient of rolling friction is smaller than the coefficient of kinetic friction. Actually, this is much less than kinetic friction.